Okie dokie, here's the continuation. Okay, so another model problem. An equilateral triangle, one with 3 equal angles and 3 equal sides, is dilated by a scale factor of 0.75. Okay, is that going to be bigger or is that going to be smaller? It's like 75%. Is that bigger than 100% or smaller? Okay, so the resulting triangle has shorter sides but angles of the same measure. That has possibilities. Has shorter sides and angles of smaller measure. Nope, nope, nope. Remember, angles remain congruent. Has longer sides but angles of the same measure. 75%. That's not longer. Has longer sides and angles of greater measure. No. All right, let me see if I can show you a quick example of what I'm talking about. Okay. This is semi-equilateral. You'll have to forgive me. All right, so there's triangle number 1. And I am going to duplicate it. Okay, so look. I am going to scale it by a factor of 0.75. Okay, the resulting triangle is smaller, but look. What happens with the angles? Notice they map completely onto each other. The angles are congruent. We good? Okay. In triangle ABC, it's similar to triangle DEF. If AB is 16 inches, DE is 12, BC is 24, what is the length of EF? What am I going to do? I'm going to draw. Okay, I'm going to pause while I draw triangles so you don't have to watch the pain. Okay, so I drew in the triangles, obviously not to scale, and it is a good way to assume everything is not drawn to scale unless they tell you it is. Now, we're going to compare them because they are similar. Okay, so what am I going to do? I'm going to compare, I think, the 16 to the 12. Okay, so 16 over 12 is going to equal, okay, since I started with the 16, I have to go to the 24 on the other. It's going to equal 24 over x. Now, we can certainly cross multiply, but I think I'm also going to try and reduce just to make life easier. So I can divide this by 4, right? And I get 4. And as long as I do the exact same thing to the bottom, I'm good. 3. Okay? So now I basically can use the fraction 4/3. So I have 4x equals 72. Okay, I'm going to come up here for a second. 4x equals 72. What am I going to do next? Divide by 4. Correct. Okay? Divide by 4, divide by 4. And the way I do this in my head, 72 divided by 2 is 36. 36 divided by 2 is 18. Try that on your calculator. That's what you're going to get. Okay, so x equals 18. Okay? Let's see what we have in store for us next. Okay, triangle ABC, similar to DEF. Okay? And I'm going to pause and draw again in a couple of seconds, but if AC is 28, DF is 24, DE is 12, what is AB? Okay, I'm going to pause and draw the triangles. Okay, and we're going to finish this one, and then there are 2 more that I want you to try on your own, or maybe we'll pause the video together, and then we're going to jump to a slightly different version of the same thing. Okay, so in triangle ABC, ABC is similar to DEF, and I labeled them backwards on purpose, but notice I went A, B, C, did the same thing, D, E, F. Okay, AC is 28, DF is 24, DE is 12. What is AB? Again, we're going to compare them. And you know what? This time I'm going to do it. I'm going to start with the smaller triangle. Okay? So I'm going to do 24. And I'm going to compare, speaking the English. I'm going to compare it to its corresponding side. Okay? And since I started with the 24, I'm going to start with the 12 on the other side. Equals 12 over x. Notice that they are matching sides. And I am so doing this the cheater's way. How do I get from 24 to 12? Divide it in half. What I do to one, I'm going to do the other. What's half of 28? X equals 14. Go us, go us. It's our birthday. Party like it's our birthday. Okay, so X equals 14. We did that in a sneaky way, and it's totally fine. Okay? Or we could have reduced it. How many times does 4 go into 24? 6. Into 28, it goes 7. But that's more complicated, so you don't even have to do it that way. Now we're going to skip the next two because I want you to pause and try them if you're watching this by yourself. If you're with me, we'll pause and do them. Okay, now check this one out. I especially like this kind of problem to do together because many people don't know what to do. The ratio of the sides of two similar triangles is 1.5 to 1. If a side of the smaller triangle is 6 inches, what's the corresponding side in the larger triangle? So watch. 1.5 to 1, that's another way of writing a ratio, is going to equal, we don't know the larger triangle, over 6. Okay? So now, again, cross multiply. 6 times 1.5. 6 times 1.5 is 9. X equals 9. Okay, and I'm going to show you some more of these. All right, if you have any questions, pause and write it down. And please feel free to ask. All right, let's look at this one. Triangle ABC is similar. Oh, I love this. Triangle ABC is similar to triangle DEF, and I'm cheating, making a funky triangle. You'll have to forgive me. Boo, boo, boo. Okay? Okay, similar triangles. Remember, that means they have the same angle measure. Okay, and I'm going to clone it so you see me cloning it. Come on with my clone. You're never alone with a clone of your own. All right, and I'm going to shrinky dink it. Okay, these triangles are similar. Okay? A, B, C. They're not really creative with their letters, are they? D, E, F. Now, if you remember what we've been saying all along about the angle measure, this is going to be a lot easier than you think. Okay? Angle A is 67 degrees. 67. Angle C is 11, obviously not drawn to scale. Okay, adding those together, you get 78. Okay, but now there's extra fluff here, which is fine. What's the measure of angle D? What does angle D match? It matches angle A. They're congruent. It's 67 degrees. Okay, they match. If I wanted angle F, it would be 11. If I wanted B and E, I would have to just subtract from 180. All right, what do you think? Okay, this is another one that I love. The lengths of the sides of a triangle have the ratio 3 to 4 to 6. The perimeter is 52. What are the lengths of the sides from smallest to largest? This is where you throw in x's. This, you're going to do 3x. Okay, that's one side. Plus another side. Oh my God. Where did I learn to speak? Plus 6x. Okay, so notice I'm throwing in x's. And the perimeter, when I add the lengths of the sides, it's going to be 52. Okay? Combine like terms. 3 and 4 is 7. 6 and 7 is 13. Or the easier way to do it, 6 and 4 is 10. Plus 3 is 13. 13x is equal to 52. 13x equals 52. Divide by 13, divide by 13. I'll be your human calculator. X is equal to 4, which is, by the way, easy if you know about decks of cards and suits. X equal 4. All right, so whenever you see those ratios there, throw in X's. All right, we're going to stop here. Ask any questions, make any comments, throw money.